Hi, so this class is about Sqoop, which is a tool which will help you to migrate the data between your traditional approach, that is RDBMS, and the new approach, that is big data. So nowadays, as you know, that most of the companies are jumping into this big data world. Every company is building the cluster, they are creating the teams, and they are exploring these emerging technologies. So the bigger companies, or I would say e-commerce websites or banks, which were storing their data in RDBMS like Oracle, Microsoft SQL Server, MySQL, or Teradata. Now the data size is increasing, and data size is increasing at very high speed. So in order to deal with that large amount of data, these companies are jumping into big data world. So you can install big data technology, you can install Hadoop, HBase, Hive, you can use them. But here the challenge is the data which is already stored in RDBMS, how to access the data into Hadoop. Because your data will be processed distributively only if your data is available inside HDFS. So what should we do? We have two options in this case. Either we can export the data from RDBMS tables to text file. That's possible. You can export your tables data into CSV, that is comma separated values, or TSV, tab separated values. And later on those text files can be very easily loaded into HDFS using copy from local command. But that is a two-way process. You have to export into text file and then you have to use copy from local command to load the data into HDFS. Similarly, when your processing is done, when you are done with execution of your Hadoop job and you have produced some desired output, the useful statistics which client will use for business enhancement, now the client is requesting to load the data back to the RDBMS. Why? Because there may be some website which is displaying those outputs, and you know that website need quick response. When you are clicking on some links, the next page is immediately displayed. That means behind the website, RDBMS can provide the data immediately. Hadoop can't do that. That means while working on daily basis, we may need to import the data from RDBMS to big data technology, or the vice versa. That means we need to export the output data from big data technology to RDBMS. So for this data movement, we need some tool. So Sqoop is an import and export tool which can help us to import and export the data between the RDBMS, that is relational database management system, and the new technologies, that is Hadoop or HBase or Hive, etc. So let's try to understand the architecture of Sqoop. You can see this. Sqoop is not a data processing technology. It is not analyzing your data. It is not running any MapReduce job or something like that. But it can help you to import or export the data between Hadoop and the SQL. That can be Oracle or Microsoft SQL Server or any other type of RDBMS. So let's do this thing practically. That would give us more clarity about this Sqoop tool. Okay, so let me log in into my Ubuntu so that we can do this thing practically. Okay, so my terminal is ready, but before that, let me tell you that I have installed MySQL on my system so that we can do this thing practically. So first of all, we will have a look how many tables are there in our RDBMS, what is the data, and then we will import. So let me open a new tab so that in that tab I can explore my MySQL DB. So I will type MySQL. Yes, MySQL is running. Now I will type show databases. Yes, there are two databases, you can see information underscore schema and test. So for learning purpose I can use the test DB. Yes, the database has been changed, and now I can do show tables. Yes, employee table is there. So I will clear the screen, and now I will do select star from employee. Yes, so we have 4 columns in this table, that is ID, or you can say employee ID, first name, last name and department. And for practical purposes I have inserted 4 rows into this table: 101, 102, 103, 104. These are 4 employee IDs. Now what we will do is, we will be importing this table's data into our Hadoop in a text file, and then we can verify whether we have really imported the right data or not. So we will be executing some sqoop command, and for that I will be opening my another tab, this one. Yes, so I am in the terminal and I will be executing the sqoop command now. So the command is quite lengthy, but we will type it slowly. This is /sqoop, then import. Yes, then for connecting to RDBMS we have to provide connect URL in single quotes, that is JDBC, that stands for Java Database Connectivity. Then my RDBMS name, that is MySQL, colon 127.0.0.1, the IP on which MySQL is installed, and finally the DB name, that is test. Yes, so JDBC colon MySQL colon /127.0.0.1/test. This combined is known as connect URL, and then we have to provide the username, because when you are installing MySQL on your system you provide some username and some password. Those 2 things will be required here for making a connection with your MySQL. So username is root and password is 1234. Yes, then target directory, in which directory your data will be actually imported. So that is target dir. I can give some name, maybe test_sqoop. Yes, then the fields terminated by, because when you are importing the data from a table to text file, data is stored in the form of rows and column in DB, that's fine, but how the columns will be stored in a text file? There must be some separator which will separate the 2 fields in a single row. So I will provide, that is fields terminated by, you can give anything, I am giving pipe. Yes, okay. Then the table name, that is employee, and finally this is the optional argument -m1. So you can provide this, and I will press enter now. So now this command should import the data from employee table which is in MySQL, and it will store the data into our HDFS. And you know, the data in HDFS can be very easily browsed through the browser. So I will be opening my browser so that we would verify this. Okay, I will go back once more. Okay, so at the root location, that test_sqoop directory will be created once the data will be imported. So let me refresh the page. Yes, you can see that test_sqoop is appearing now. I will click on that. Yes, and you will find the last file which contains the actual data. The initial 2 files _success and _logs are system file, which you can ignore as of now. So I will click on the last file which contains our output, and let me zoom in so that you can have a closer look. Yes, you can see that The data is beautifully displayed. 101, then pipe, Neeraj, pipe, Kumar, pipe, big data. Similarly, the remaining 3 rows. Shall I show you the data once again so that you can check? We have actually the same data which was there in your MySQL employee table. You can see this. So the data which was there in the table, that has been successfully imported into HDFS. And once your data is available in HDFS, that means it has been separated into smaller parts and stored distributively on multiple machines. That means if you will process this data, if you will execute any Hadoop job on this data, that Hadoop job will be executed parallelly on multiple machines. Hence we can deal with large amount of data in very less amount of time. So this was just one example of importing the data from Hadoop MySQL to Hadoop. Similarly, you can export the data back from HDFS to MySQL. Similarly, you can import and export the data between MySQL and HBase and MySQL and Hive. And it is not only for MySQL. You can import or export the data with any RDBMS. That can be Oracle, Microsoft SQL Server, MySQL, IBM DB2, Sybase or Teradata. So this is all about the import and export tool. Thank you.